Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Binary Sum Arrows, and it's by Rocky Rower. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, in this case a box. We also need to color the grid such that every odd cell is one color and every even cell is a different color. So what I usually use, well, I said that twice. What I usually use is red for odds and blues for even. I don't know why I chose it, but that's the way I chose it. Arrows are not normal arrows, but contain binary sums. Each cell along the arrow is a bit, starting with the most significant bit and going to the least significant bit. Okay? If a cell contents are odd, that puts a 1 in that bit, and if a cell's contents are even, that puts a 0 in that bit. And digits in the bulb are the binary sum expressed as 1 or 2 digit decimal numbers, read from left to right, so from left to right, or from top to bottom. For example, a 5-cell arrow would have a 16th bit, an 8th bit, a 4th bit, a 2th bit, and a 1th bit. Okay, so let's use that. So cells with odd, even along that arrow would give a binary sum of 16 plus 8 plus 0 plus 0 plus 1, which would be 25. So let's use this as an example because this is 5 digits. So, along this is the 16th bit. So okay, so I don't know if you guys know what bit representation is, but essentially it's basically binary representation. You either have a 0 or 1 in each place, right? That is essentially multiplied by the multiple of 2 that you have. So here it'd be multiplied by 2 to the whatever the position is. So if it's the furthest right most position, that is position 1 considered, and you subtract 1 from that. So this would be 2 to the 0th power, which is 1, times whatever the bit is. So if it's 0, it's obviously 0. If it's 1, it's 1. This would be 2 to the 2 minus 1, because it's the second position. So that's 2 to the first power, which is 2 times whatever that digit is. If it's 0, it's 0. If it's 1, it becomes 2 as a sum, right? Same with this. This is 2 to the 3 minus 1 power. So it must be 2 to the second, which is 4. So if you have 4 times, that's why you have, that's the 4's bit, this is the 2's bit, this is the 1's bit, this is the 8's bit, and this is the 16th bit, right? 8 is equal to 2 to the third power, which is 4 minus 1. And 16 is equal to 2 to the fourth power, which is 5 minus 1. So that's how you can that's how you essentially determine what a binary number is. So let's say we had odd, even, odd. This is 16 because it's 1 times 16. This is 8 because it's 1 times 8. This is 0 because it's 0 times 4, 0 times 2, 1 times 1. So therefore it'd be the sum of all of these, which is 16 plus 8 plus 1, which would be 25. So this would guarantee that this is 25 if you had this coloring. And that's how the binary sum arrows work. And again, it's read from left to right or top to bottom for the decimal number here. And it's read from the from the pill or the circle down to the tip of the arrow to where the binary number is read. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so what do we have then? Do we have any valid information? We know all of these are the even and odd digits adding up to certain values. This is, again, this is the 8th digit, 4s, 2s, and 1s. This is 2s and 1s. 8, 4, 2, 1, that's the maximum value for this cell. So that means this has to be, at maximum, 8 plus 4, which is 12, plus 2, which is 14, plus 1, which is 15. So we're guaranteed this has to be a 1 here. So this is 1, which is odd. You cannot have 4, 2, and 1 here, and this be even. So this bit has to be on. If it's not on, this is at maximum 7. So this must be on, which means this is odd. This is 2, 3, 4, 5. We're not sure which. So it's at least 12. Since it's at least 12, you need an 8 and a 4 to be on. So this is 12. Then you could have 3 and 5. So if you have all of them on, you would have 5 odd digits already in row 1, but that would add up to 15. So this can never be 15 then. We could have 2 evens, and that would be 2. This cannot be 1. So this is either 2 or 3 here, adding up, right? Because it cannot be a single digit here. If this were 3, this would have to be on and on. So you'd have 3 odd digits here. These are guaranteed odd. This is guaranteed odd. So that's 6 odd digits in row 1, which is not allowed. This cannot be 3. This must be 2, which means this must be on, and this must be off. So this is off. That means this can't be 12. This is either 13 or 14. If it's 13 or 14, one of these two has to be odd. We have already 5 odds then, which means this can't be 13. This is 14. So this is guaranteed an even. That means we have, to add up to 14, it must be 8, 4, and 2. So this must be on, and this must be even. So that's the coloring there. This, again, must be 2 or 3. It could be 2 digits here. So it's 2 or 3. Since it's 2 or 3, this must be on. So this, because if it's 2, it's 1, 0. If it's 3, it's 1, 1. Because it cannot be 1 here. It can't be 4, because 3 is the max here. The max here is 7. Okay. We don't know what this is. The max here is 7. It could be, so it could be 1, 2, 3, 4, 5, 6, 7. We're not guaranteed anything here. We know one of these is on. We don't know which, though, or how many. Okay, so for 3 cells, you can only add up to 7. So this is 1 through 7. This is 1 through 7. For 4 cells on the arrow, so this also must be 1 and something, right? This is 4 digits at most. That means it adds up to 15 at most. So this is 1. It has to be with 3, 4, 5. To be with 3, 4, 5, both of these must be odd. So these must be odd to be on. We have one of these be odd. If this is 15, that would mean guaranteed all 4 of these are on, right? 8 plus 4 plus 2 plus 1 is 15. But the problem is then we would have 6 odd digits in column 7. So that's not allowed. So this cannot be 15. Therefore, we know this is 13 or 14. One of these two is odd, one is even. We don't know which is which. Let's see. So, if this is even, the problem with that being even is that this would add up to at most 15. And we can't have a 1 in that position. So this has to be odd and on. So it's 16. We need at least one of these here. What can be the maximum value? I think it's 31, right? Because it's usually 2 to the whatever power, however many digits it is, 2 to the 5, minus 1 specifically, right? Because this can be 16 times 1, 8, 16 plus 8 plus 4 plus 2 plus 1. And that's essentially 1 minus 2 to the 5th power. 16 plus 8 is 24. 24 plus 4 is 28. 28 plus 2 is 30. 30 plus 1 is 31. So this is 2 or 3 also, which means in this box 1, we have a 2-3 pair. That leaves the remaining digits that are odd as 5, 7, and 9. So this must be a 5, 7, 9 pair. This must be 6 and 8. This must be 6 and 8. So both of these are even. So it can't, this is 6 or 8. That means this cannot be 3. This has to be a 2. Because we have 31 at maximum here. So this is a 2. This is then 3. So this is odd. This is even. That means both of these must be turned on because 2 plus 1 is 3 here. So this cannot be 3 here. This is 26 or 28. 26 in binary notation is a 16. We need an 8. What else do we need? 16 plus 8 is 24. It's either plus 2 or plus 4. So one of these is odd and one is even. And this has to be even to be off. So one of these is odd, one of these is even. That means these are both odd digits. So we have 1, 3, 5, 7, 9 here. Obviously, this can't be... This is 6 unique digits. So... Or 6 bits, essentially. So that's 1, 2, 4, 8, 16, 32. So it could be 63 at most. So this cannot be 7 or 9. One of these two must be odd to add up to 26 or 28 in binary. We have 16, 8 plus either 4 or plus 2. Therefore, in box 2, we have 5 odd digits, which means these two must be even. So since this is even, this cannot be 1, it cannot be 5, it cannot be 7. This is 2, 4, or 6, which means the 1's digit must be off, which is even. And the rest of the digits, we have already 4 even digits in box 3, so the rest must be odd. So these are odd, which makes these on. This is 4, this is 2, therefore this is 6 here. This 6 eliminates 6 here, so this is 8, this is 26. To add up to 26, you need 16, 8, and 2. So this is odd, this must be even. We have 3 odd digits here. That means in column 8, the rest of the digits must have 2 odds and 4 evens, which means 4 of the bits are 0. Okay. This is odd. We have an odd here and 2 odds here. One of these two must be odd to add up to 13 or 14. So one of these is odd, which means we have 5 odds already in column 7. So this cannot be odd. This must be even. So this is 14, which means this is 8 plus 4 plus 2. So this is odd, and this must be even. This can't be 2, 4, or 6, so this must be 8, which makes this a 6. This must be a 4, 6 pair. This cannot be 2, 4, or 8, so this is 6. This must be 4. This can't be 2, 6, or 4, so this is 8. This can't be 4, 6, or 8, so this is 2. This must be 4 then. Okay. 14. Again, like here, this must have, okay, it cannot add up to 1 something. So it can't be the teens. It can't be 20 something. This is at least 30 something. And it can't be 31. It could be 32. So this is at least 3. And it has to be at least 32. So since this is at least 32, this must be on. Right? We know there are 2 on digits here, so it can't technically be 32. But it must be at least 32, because this can't be 1 or 2 because of the 1 or 2 in the column. So this tens digit is a 3 at least. So it could be 3, 4, 5, or 6 here. Obviously, this could be any non-digit here. No 1, 3, 4, or 6. So 2, 5, 7, 8, 9. This can't be 3, 4, or 6. Also, I don't think this can be an odd digit. If this were odd, that guarantees this is a digit, so that would be 33. This is always on, so this has to be 1 or 3. It cannot be 1. This is a 3. Oh, there we go. So this cannot be 30-something. It must be 40-something, or 50-something, or 60-something. Well, the only way you can add together to have with 2 bits set is 32 and 16. So this must be 48. So these are both even, which means this must be odd, this must be odd, and all 4 of these are even, right? So we have, this is 1's digit 0, 2, 4, 8, 16, plus 32 is 48. So these 2 are on. This must be a 1. That's the only digit remaining. This can't be 1. This is 2, 5, or 7. If this were 2, that would mean there are no even digits here. So that would therefore be 4 plus 2 plus 1. So this can never be 2. This must be 5 or 7. We don't know which. Okay. 5 or 7, we need the 4 turned on either way. 5 or 7, we need the 1's digit turned on, so both of these are odd. This is odd also. Okay. The 8 digit could be here. Okay, you have only 1 digit turned off here. Amongst, at most, right? Either, so you cannot have all 4 on, because that would be a 2-digit number, right? You'd have 8, 4, 2, and 1 added together, which adds up to 15. One of them has to be guaranteed off, but that's it. That's the most we can have. It can't be all 4 on. It can't be this on with 2 others, because this is the minimum, which would be 8 plus 2 plus 1, which is 11. So this can never be on. This has to be off, which forces all of these to be on. Therefore, this adds up to 1 plus 2 plus 4, which is 7. So this is 7, this is 5. That makes this even. We have 4 evens in column 2. That forces this to be odd. This is odd. That makes this a 9. This must be a 1, 7 pair here. That leaves us as 3, 5, 9 here. Well, this digit cannot be 2, 4, 8, so this must be 6, which makes this 2. That makes this a 2 here, which makes this 4, 6, and 8 here. This can't be 6 because of the 6 in the row. Okay. What else do we have? There are at least... Okay, this cannot be 1, 3, or 4. So this is the ones digit, 2, 4, 8, 16, 32. So it adds up to 63 at most. So this is cannot be 1, 2, 3, or 4. This is 5 or 6 here. So as the tens digit, it's a 5 or a 6. That's interesting. We can only have 4 turned on here. So the most would be 1 plus 2 plus 3 plus 4. That would be 32 plus 16, 48, plus 8, 56, plus 4, which is 60. But 0 can never be in normal Sudoku. So this is 50-something. So this is a 5, which makes this odd. It's 50-something, so we need the 32-bit turned on and the 16-bit turned on. So these are both odds. So that adds up to 48. We don't know about the 8. 8 could be on or could be off. We're not sure. Hmm. This could be all 3 on. This digit cannot be 1, 2. It could be 3, no 4, no 5, no. It could be 6 or 8. 53 or 56 or 58. If it's 53, that would require the 32-bit, the 16-bit on. That's 48 plus 5. So it would be this and this on. If it's 56, so it would be on and on here. If it's 56, that would be 48 minus... So 56 minus 48 is 8. So it would have to be the 32, the 16, and the 8 on, but the rest would be off, but that's not allowed. So this cannot, because we already have... We are guaranteed to have 2 off here instead of... If you have 3 off, that means 5 even digits in column 6, which is not allowed. So this cannot be 56. If it's 58, that would guarantee it's 16... Sorry, 32 plus 16, 48, plus 10, which would be 8 and 2. So these we just don't know. It's either these two are odd and these two are even, or these two are odd and these two are even. We're just not sure. Okay. This must have 2 on and 2 on and the rest are off. So what are the possible combinations? It's a 2-digit number. And they're both odd digits. Since they're both odd, this must be on to form an odd binary sum. Because they're both odd, then what are the possibilities? Something plus 1. So you could have 16 plus 1 or 32 plus 1. So the 2's digit is off, the 4's digit is off, the 8's digit is off. So it's either 17 or it would be 33 here, which is not valid because you would have two 3's in the same row, which is not valid. Therefore, it must be 17. So this is 1, this is 7. And the 16-bit is turned on. So this is off. This cannot be 4 or 8. It's 2 or 6 here. This is 2. Cannot be 2 or 6 or 4. So this is an 8 here. 6 cannot be either of these cells. So where is the 6 in column 8? It must be here. So this is 6. This must be a 2-4 pair here. Okay. We have in row 5, we have 5 odds. That means the rest of the row is not odd. It's even. So this is even. So this is even, and this is even. That makes this 58, and this must be on, so it's odd, and this is on, so that's odd. These are evens. To add up to 32 plus 16 is 48, plus 8 is 56, plus 2 is 58. So this cannot be 6, 4, or 8, so this is a 2, which makes this a 6. Only one digit can be turned off here. So you cannot have a 1 or 2 here because that would require 2 digits turned off. You could have a 3. You cannot have 4. You can't have 6 because of the 6 in the column. So that means the 1's digit is always turned on. So this is on. And we either have 2 odd digits here, an odd digit here, an odd digit here, even digit, or 3 odd digits, and this is even. But this sees all 2, 4, 6, and 8 in the column, so this cannot be even. This is odd, which means this can't be all odd. One of these is even. So this is odd. We have this is 2 or 4. This is 2 or 4. This 2, 4, 2, 4 pair eliminates 2 and 4 in the rest of the row, so this can't be 4. This 2 eliminates 2 here, so this is a 4, which makes this 2, which makes this 4, which makes that 2. This can no longer be 4. We have a 6, 8, 6, 8 pair in column 3, which eliminates 6 and 8 in the rest of the column. This can't be 8. This is a 4. Okay, so in box 5, we already have 5 odd digits. So that eliminates odd digits in the rest of the box. So this is even, and this is even. We have 4 evens in row 4. That eliminates evens in the rest of the row, so this is odd. And we have 4 evens in box 6, so this must be odd also. That leaves this as a 4 to be the only even. This is 2. What else do we have? 3 and 5. Okay, this 7 eliminates 7 here. Where is the 1 in row 2? Can't be any of these because the 1 in the box eliminates it. It can't be any of these because the 1 in the box eliminates it, so it must be here. So this is 1. The rest of this is 5, 7, and 9. Where is the 7 in row 2? Can't be here because the 7 eliminates in the box eliminates that. So it must be here. So this is 7, which means this cannot be 7. This is 5 or 9. This becomes 3, 5, or 9 here. The remaining digits in row 4 have to be 7 and 9. This can't be 7 because of the 7 in the column, so this is 9, this is 7. We have 3, 5, and 7 remaining. What's row 5? We have 3 and 5 remaining in the odd digits. So this is 3 or 5, this is 3 or 5. This cannot be 3 or 5. This can't be 7. Where is the 7 in box 7? It has to be this cell. So this is 7. Therefore, this is 3 or 5. This can't be 5 because of the 5 in the row. So this is 3, which forces this to be 5, which forces this to be 3. 5 eliminates 5 here. This becomes a 3, 9 pair, which eliminates 3 and 9 in the rest of the box. This can't be 3 or 9, so this is 5. What's the last remaining digit? It must be 7. Therefore, this must be a 1, 9 pair here. This 3 eliminates 3 here, so this can't be 3. It's 9, which makes this 3. This has to have 3, 5, 9 remaining in row 3, and 3 can't be here. So where's the 3 in row 3? It must be here. That eliminates 3 here, so this is 5. That means the 4 bit is turned on and the 2 bits turned off. We have 4 even digits in row 8, which means the rest of the row cannot be even, so there must be odd and odd. We have 5 odd digits in row 7, which means the rest of the row cannot be odd, so this is even. We have 4 even digits in column 9, which means the rest of the digits are odd here. This is odd, and we have 5 odd digits in column 4 or box 8, whichever one you want to choose, which means the last remaining digit is even. So this is even, this is 8. This is 6 or 8, but it can't be 2, 4, or 8, so this must be 6. That 6 eliminates 6 here, so this is 8, this is 6, this must be 8. Okay. Remaining digits. This is 5 or 9. 5 cannot be in columns 4 or 5 for box 2, so this has to actually be a 5, which makes this 9, which makes that 5. This must be a 7-9 pair here in row 1. We also have a 7-9 pair in column 4. This 7 eliminates 7 here, so this is 1, which makes this 7. This can't be 5. Where is the 1 in row 7? Can't be here because of the 1 in the column, and the rest is all filled out. And this can't be 1 because of the 1 in the column, so this must be a 1. This is a 1, which makes this not 1, so it's 9. This is 1. 9 eliminates 9 here, so it's 7 and 9. 9 eliminates 9 here, so this is 7. The last remaining digit in column 5 is a 3. The last remaining digit in column 6 is a 9. So this 3 eliminates 3 here. We have a 5-9-5-9 pair in row 9, which eliminates 9 here because of the 9 in the column. So this is 5, which makes this 9, which makes this 3, which makes that 5. That 3 makes this a 9. This has to be a 3, and this must be a 1. And that's how you solve it. Yeah, I mean, this is pretty much binary sums. So, pretty cool concept, actually. I like it. But then in my previous life, I was a software programmer, so I'm very used to these bit manipulation stuff. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.